Characters of equilibrium constant, chemical equilibrium or equilibrium constant. Some of the important character of chemical equilibrium are as first one, at equilibrium, the concentration of each of the reactant and product become constant. That is what the first point. At equilibrium, the concentration of reactant and product become constant, not equal, constant. The experiment showing that constancy of the pressure in the evaporation of water or decomposition of calcium carbonate and consistency of color of equilibrium in the decomposition of N2O4 already discussed prove that above characteristics. This may be represented graphically for a general reversible reaction. A plus B gives reversibly C plus D. Second point, at equilibrium, the rate of forward reaction become equal to the rate of backward reaction and hence the equilibrium is dynamic in nature. The experimental proof for this property have already been discussed. The experimental proof, okay. Next one, chemical equilibrium can be established only if none of the product allowed to scrap out or separate out as solid. This is obvious because if any product is allowed to escape out, CO2 gas, in case of decomposition of CaCO3, the reaction will no longer remain reversible. A chemical equilibrium has meaning only for the reversible reaction. Similarly, the reaction is reversible if one of the products separate out as solid. This is so this will become irreversible. Chemical equilibrium can be attained from either direction, from the direction of the reactant as well as from the direction of product. To understand these characteristics, let us consider that N2O4 giving 2NO2. Suppose two identical glass bulb A and B are filled with NO2 gas at the same pressure. The bulb A placed in ice and the bulb B is placed in boiling water. The gas in bulb A is found to be almost colorless, whereas in bulb B it is found to be reddish brown. Experiments show that most of the molecule in the bulb have the formula N2O4, whereas most of the molecule in bulb B have the formula NO2. Now suppose both the bulb are placed in the vessel containing water at 298 Kelvin. It observed that the color in bulb A depends when the color in bulb B fade. Obviously the reaction taking place in bulb A. So this is what the condition is, student. Thank you so much for watching.